Okay, this video is how to do a freezing point depression problem. The first thing that you would need to know is the formula for freezing point depression. So it goes like this. It goes the change in temperature. That's important. That's the change in temperature. They put a little F down here so you know it's freezing point. Equals I KF and then little m. Okay? So this right there, that stands for change in temperature. I, that's called the Van't Hoff factor. I'll show you how to find that. KF, that's the freezing point depression constant. So that's a constant that you will have to look up in a book or it will be given to you. You don't have to memorize it. And the M, that's your molality. So if we get this problem here and we want to find the freezing point, we have to first, we'll have the formula here, and then what we'll do is we'll plug the numbers into it. So change in temperature freezing equals I KF M. All right, so what we're going to solve for is we're going to solve for the change in temperature is what we're going to solve for first. Okay, now the I is the Van't Hoff factor. And you get the Van't Hoff factor by writing the dissociation equation. So if we have magnesium nitrate, which is MgNO3 and when you put magnesium nitrate and it goes into solution, you get one mole of magnesium ion and then you get 2 moles of nitrate ion. So you're just writing the dissociation equation, but basically for every 1 mole of this that you dissolve, you get 1 mole of magnesium plus 2 moles of nitrate. So the I, or the Van't Hoff factor, is equal to whatever this number is in front of this ion and whatever this number is in front of that ion. So 1 plus 2 is 3. So the Van't Hoff factor is you add together the moles of ions that something breaks into when it goes into solution. So for this problem, the Van't Hoff factor is 3. So I'm going to start figuring out all these things and plugging them in. So I is 3. Okay, KF is the freezing point depression constant. So it's equal to 1.86 degrees Celsius divided by little m. Now that's just the units. So you write 1.86 degrees Celsius over little m. Little m stands for molality. Now we have to find the molality. Remember that molality, okay, which is little m, equals moles of solute divided by kilograms of solvent. So we don't know what little m is, but we got to figure out the moles. All right, and so we have another step here. So to get moles, when we know grams, we have to change this number of grams into moles. So we're going to go 45.9 grams magnesium nitrate, and then we're going to draw a picket fence, and we're going to say for every 1 mole there, I did this wrong, for every 1 mole, so we don't want moles here because we got grams here, so we got to have grams here. For every 1 mole there's 148 grams. That's the molar mass. So if you do the math there, you end up with 0.31 moles. So I'm going to write that right here, 0.31 moles. And then I got to divide that by the kilograms. Well, here we have 750 milliliters. If you remember, we're just going to move the decimal 3 spots on that. So we're going to get 0.75 kilograms. And so if we do the math there, the molality is going to be equal to 0.41, okay, little m. Okay, so we're going to multiply this times 0.41 little m. And if you notice, the little m's cancel, and then you're left with degrees Celsius. So if I do all this math, I end up with the change in temperature for the freezing point depression is 2.3 degrees Celsius if you do this math. And that's not the final answer, because the final answer wants to know the freezing point. All right? So we know water usually freezes at 0 degrees Celsius. What this equation that we just worked out tells you how much that's going to go. Okay? How much that's going to change. It's a change in temperature. And in this case, it's called freezing point depression. So when you add something to water, it lowers the freezing point. So you have to subtract 2.3 from 0, so you end up getting a negative 2.3 degrees Celsius. That's the final answer. So the final answer is negative 2.3 degrees Celsius. Okay, to review, let's review. Step 1, write the formula out for the freezing point depression. Okay, step 2, write the dissociation equation to figure out the I, which we know is 3. From doing that, 1 plus 2 is 3. Put that in there. Okay, the next thing to do, okay, the third thing to do is to find what the freezing point constant is. You'd look that up, or it'll be given to you on a test or wherever. You just look it up and put that in. But there's also a boiling point one, so you got to make sure you put the right one in. This one's the freezing point depression constant. All right, and so then the last, well, not the last thing necessarily, but the next thing is you have to get the molality. Okay, remember, so you're going to take the moles divided by the kilograms. So you have to get the molality. All right, and so you'll plug that in. You'll get the answer. The last thing that you're going to do is subtract the answer, the change in temperature, from 0, because that's when water, well, that's the temperature at which water freezes at, to get the final temperature or the freezing point. Okay, that's it with that video.